First off, delta S equals positive. Does that mean entropy increases or decreases? Increases. All right, delta S equals negative, entropy decreases. I guess I'll turn my fan on since Goddard won't turn his on. The smoke from that is quite thick and heavy. He just burned wood in a test tube. All right. This is tricky because the delta H, remember the positives and the negatives are a little bit different than normal. But anyway, we'll be all right. So, if we look up here, when we go from a liquid to a gas, does entropy increase or decrease? Increases. So delta S is positive. When we take something aqueous and form a solid from it, does entropy increase or decrease? Decreases. So that would be a negative sign. All right? When we take a solid and a gas and convert it to just a solid, is that entropy increasing or decreasing? Decreasing. So that would be a negative value. All right, and then we have a mole of gas going to 2 moles of gas. This one's really very small difference, but we end up with only like 1 reactant. Really, this is almost going to be 0. But if we decrease the amount of independent things and tie them together, it also decreases. Okay? This one, really, you could get away with saying no change because it is essentially not measurable. But there's slightly more order to this one than there was to that one. Okay, are we okay with what makes entropy increase and decrease? Silence means of course. All right. This is the exact same type of question. Would you like to do this one without spending too much time? When a solid goes to a gas, is entropy increasing or decreasing? Increasing. When we go from solid gas to solid, it's decreasing, right? Gas, gas, solid, it's decreasing. Gas, gas, gas. This time, this one actually does sort of make sense. It goes from 3 to 2 moles of gas, right? When we decrease moles of gaseous product, well, not product, stuff, entropy decreases. Were we 100% on that one? I see someone eraser going. Oh, I wasn't naming names. Okay. Here we go. All the answers were just circled, but we'll be okay. Choose the sample of matter that has greater entropy in each pair and explain your choice. Right now, just circle them. Don't worry about your explanation. Circle them, and then how about you turn to your lab partner and explain one of the 3, and then they do them back to you. Still recording. Well, that's going to be boring. That's the only one line I owe you. I told them when you were not here. We can do all sorts of whatever you want after the AP test. Okay, next up. Using standard entropies in Appendix C. We're going to refer to Appendix C a ton today. Most of you don't have your book. On a couple of them, I've written them in. I'll have to look them up for you in the book, probably. Calculate the standard entropy change for the following reaction. delta S naught was equal to sum of products minus sum of reactants. Ready, set, go. Record the part that couldn't be more worthless. So anyway, there you go. Internet people that won't ever look at it again. Okay, this process repeats itself a lot. We can do the same process for delta H, you remember, and delta G. It's the same idea, you just will look at different values. Okay, sum of products minus the sum of the reactants. Next. What? No. This process is always P minus R. Always. All right. By using data from Appendix C, calculate the standard free energy change for the following reaction. Thank you so much. I'll cover your stuff with that. Your what? Record something that was important. What's that? I want to roll today. So yesterday was a really rough one, and I was up really late, and I'm a little bit not myself. So sorry that I suck today. Okay. Let's see here. Let's move to this one. The previous one was a lot like the one we did before. So, this one is all about thinking. So it says, without using data from Appendix C, predict whether delta G for this reaction is more negative or less negative than delta H. All right? In order to figure that out, you have to think through this whole thing. What's the equation for delta G? Delta H minus delta S, right? So in order to compare these to these, you have to know delta S. So this question combines the very first two questions we did and this equation. So try and think that through for a minute or two, and then we'll talk it through. Someone's in charge. What? Why? It's Diane's birthday. I can't swear on her birthday. But I can record this worthless part of this. That's your birthday present that you want me to say, damn? Oh, no.
You swore recording.
I was talking about Flaming Gorge. Okay. Glen Canyon. Like, you name it. I'll damn it. Okay. Here we go. One more time. Since we go from 6 moles of gas down to 3 moles of gas, entropy decreases, which is a negative sign. All right. So that means this term right here is negative, right? A negative minus a negative is really a what? Positive. Okay, so now we can answer this. Delta G for this reaction is more or less negative? Well, this was a negative 2,2,2,0, and I will always be adding a value, right? So it becomes less negative. We okay with that? All right. Then it says, use data from Appendix C to calculate the standard free energy change for the reaction at 298. Is your prediction correct? I'd have to make these numbers up. Let's see if these numbers exist without the actual answer being shown. Okay, this was worthwhile. I'm so glad. Yeah, like, spoiler alert, there's nothing here. Okay, crap. Okay, Appendix C is in your textbook. If it's on a test, it will give you this data because you don't get to use your book. It gives you delta H, delta G, delta S naught values at 25 degrees Celsius, or 298. Okay. In Appendix C, I'm going to pause this, but I'll write these values down with the delta S values and delta H, as you guys pointed out. Thank you that it gave it to us. We can now solve this problem. Error? That's not good. Oh, crap. What did this number end up being? Does that look right, everybody? And what does that end up being? 1518? Okay. Yeah. Okay, hey, is this process spontaneous? Yes. If G is negative, it's spontaneous. Okay, did this answer prove our prediction? Yeah, this number is less negative, which means closer to being positive than that number is. Okay, there was one other type of practice problem I definitely wanted to do. We'll work on that tomorrow. I haven't decided if I even want to give you a test.
I'm already
A short quiz. Should give you a 2-question test. 1, who's your favorite teacher ever? That is a pass-fail.